A 117.4 Newton bird feeder is supported by 3 cables as shown in the figure below. Find the tension in each cable. So we have our 3 cables here, one at 60 degrees, one at 30 degrees, and then the tension of the cable holding up the bird food. Again, I drew the same diagram here, and then the first thing you want to do is actually draw the free body diagram. So the center point here is going to be where all the tension is on each of the strings. That would be this point here. And then you're going to have your MG going down, your F1 and your F2 going up at the same angles, because this angle is going to equal this angle right here like this. Same thing with the 60 degree. So since these are vectors, we need to add them, and they are not in line with the x or y axis, so we must find the components of the x and y in order to find the actual value of the force. So first thing, or what I usually do is I draw x and y out, F1, F2, and mg. So to find the x component of F1, you're going to have to take the cosine of 30 times the actual force. So F1 cosine of 30 adjacent over hypotenuse. And same thing for the y value, or for the F2 value. F2 cosine of 60 degrees. And since this x value, this is our y axis and our x axis, and since the x value is going left towards the left direction, it's actually going to be a negative. So this will be a negative sign here. And for the y values, we will take F1 sine of 30 opposite over adjacent or hypotenuse, and F2 sine of 60. And since both of these are in the up direction, they're going to be positive. So for the mg, it is only in the y-axis. There's no value in the x-axis, so the x component is going to be 0, and the y component will then be negative mg because it's going down. So now we can add up our x and y components, and we get F1 cosine of 30 minus F2 cosine of 60 plus 0. And our y components are going to be F1 sine of 30 plus F2 sine of 60 minus mass times gravity. And that's going to equal 0 because the sum of forces equals ma, and there's no acceleration in this problem because it is at rest, so this is equal to 0. So this equals that, which equals 0. So now we have to solve for one of the forces, and since there's an F1 and an F2 in this problem, we can use something called substitution using this equation to solve for F2 or F1. So if we take this equation and we solve for F2, we get F2 cosine of 60. F2 cosine of 60 divided by cosine of 30 gives us our value of F1. Sorry, I said F2 in the beginning. So now we can plug this value in for F2, and we get the new equation of F1 sine of 30 plus, we're going to plug this in for F2, we plug this in for f1. So f2 cosine 60 divided by cosine of 30 times the sine of 30 plus f2 sine of 60 minus our mg, which is actually equal to 117.4. Because the weight is equal to mg equals 0. So now we can simplify this equation a little bit so it's easier to understand. And by doing that, we can take cosine of 60 times the cosine, or times the sine of 30 divided by the cosine of 30. Here we end up getting a value of f2 times 0.29 or 0.289. That's better. And plus f2 sine of 60. So the sine of 60 is equal to 0.866. 0.866 minus 117.4 equals 0. Now we have to solve this problem for f2. And we end up getting 117.4 divided by these two values. Actually, we'll just carry it out. So f2, we can factor that out. It's equal to 0.289 plus 0.866 equals 117.4. So 117.4 divided by 0.289 plus 0.866 is equal to 101.6. And that is our value for the left cable, f2. Okay, now to find f1, we can plug in this value for f2 into this equation to find f1. So 101.6 times the cosine of 60 divided by the cosine of 30 is going to equal 58.766. That's 4 sig figs. And then, so that was 58.6 and then the bottom cable here is actually just going to be 117.4. Because that's the only thing acting on it. So, hope this helps.